goal of this type of approaches, restorative medicine, is to restore either the nigrostriatal system, so the anatomy of what's degenerating in Parkinson's, or which might mean the same thing in the end, the dopaminergic transmission. So it can be seen in terms of anatomical effect, but also biochemical effect. And in terms of advantages, there are multiple advantages. I would say probably the biggest advantage is that this is something that is trying to tap into the biology of the neurodegenerative processes, and therefore there is a possibility that this will have a bigger impact on disease progression. So it will act as a symptomatic treatment, but at the same time also as a disease-modifying effect. And all the other options we have at the moment, and thankfully we have many options to treat Parkinson's disease symptoms and signs, don't have an effect on the progression of the disease. So that's why everybody, particularly patients, I would say, are interested in this type of treatments. When we look at restorative treatments for Parkinson's, there are at least 4 pillars that we need to keep into account. So it would be better for me to give you an overview one by one. I will start with the one that is explored the least. That is an approach through which there's an attempt of changing the nature of local tissue. So Parkinson's disease, there are multiple areas of the brain degenerating. Actually, it's important also to emphasize that it's not just a nigrostriatal problem, it's not just a dopaminergic problem, but focusing on that particular structure in the substantia nigra, as we all know, there are neurons producing dopamine that little by little die. So one of the first approaches, like I said already, not very well studied at the moment, is to change somehow the nature of local tissue, for example, glia in that zone or other neurons, to make sure that they become dopaminergic neurons and they start producing dopamine and re-innervating theory the striatum. This is not just the least stuff, but it's also the most difficult, and that's probably why it's not very successful, and probably there's not much else to say in this regard. There have been attempts, obviously, but nothing really worth being mentioned at this point. The other approach is the gene therapy, usually through viral vectors. So the understanding of genetics has increased a lot in recent years, and also how we can manipulate genes. And this can be done, like I said already, through viral vectors that are sent to the brain in different ways so that they can be in the cells, in the neurons, and we can give them a gene that was missing or it wasn't underexpressed. Another way, which is also part of gene therapy, is using more modern techniques like ASO and interference with NRA. So another possible strategy like CRISP, although there's not much at the moment, at least in humans. So gene editing sort of thing. Then there's a third one that is the use of neurotrophic factors, for example, GDNF. And these growth factors or neurotrophic factors can be implanted in the brain in different ways, including gene therapy. So instead of giving them to the brain, we can give them additional genes to produce these neurotrophic factors. And lastly, and this is probably the most interesting at this moment, and the one that is studied the most, is based on cell replacement therapy. So replacing these neurons, more than the neurons, actually the terminals in the striatum, inserting in the striatum either fetal tissue taken from embryos, which comes with a lot of logistical problems, including ethical ones, or the so-called, the new approaches, floor plate protocols, where we can engineer certain type of cells and we can make them precursor of dopaminergic neurons, even without using embryons. And there are different types of this, and they can be implanted in the striatum. So 4, just to recap, changing the local environment to make them dopaminergic, not too much else to say. Gene therapy. There are studies, many more will come in the near future. Neurotrophic factors, not too much unless we start looking into genetic ways to produce neurotrophic factor. These are where mainly studies done in the past. And the most active one is cell replacement therapy. And this is actually where I spend most of my time during my presentation in Montreal.